Hello there, welcome back to another session talking about Data Centre Interconnects and Layer 3 Data Centre Interconnects. Today's subject matter that we're going to be talking about is Layer 3 VMotion, and if you haven't spotted him already, we've got a very special guest on today, a good friend and mentor for CCIE service provider, Piotr Jablonski. So Piotr, thanks very much for joining us today. How are you?
Hello, everyone. Hi, Malcolm. Thank you for invitation. I'm fine, and let's do the stuff then.
Brilliant. So before we start, you just want to give a very quick update because you've been around the block a bit. So what are you doing these days?
Yeah, and at this moment I'm running the company which is doing firewall translator and generator based on NetFlow and syslog, and also in the next phase we are gonna to produce something around intent-based security and also governance between asset management, security policy, and flow monitoring. And apart from that, I'm an instructor and consultant for public cloud and security and networking stuff.
Yeah, and ex-Cisco, ex-VMware, so a lot of experience in the data center side of things and VMotion, etc. So that's why, I thought it was a good idea to invite you on for a chat today. So thanks again, really appreciate it. So, what we're going to do is we're just going to have a quick chat. Some of the historical stuff around VMotion. What is it? What are the layer 2 requirements? Why have we historically used layer 2? And what are some of the challenges with it? So I don't know if you want to take over there and just give a bit of a background, Piotr.
Yeah, layer VMotion is layer 2 VMotion is quite old right now, and it provides simply option to move virtual machine in a cold or hot manner, so without, let's say, losing the connectivity, but in the sense that we don't lose the session, but of course some packets are lost during that VMotion. And essentially we have the possibility to move virtual machine within the same subnet across different locations or racks for the maintenance purposes. Later on, VMware used this feature to propose high availability architecture, but as we know it, this feature is also imposing several issues, and we will talk about this a bit later.
Brilliant. And historically, was that more confined within a data center, and then as companies started introducing DR data centers, then the requirement came up that we needed to, that feature was there for intra data center, then we started having to introduce it between data centers. Is that how it's kind of evolved?
Yeah, site recovery manager is or disaster recovery purposes, is one of the purpose where this feature was used and introduced and heavily advertised with.
Brilliant. So if we move on to layer 3 VMotion, and if you want to give a little bit of a background as to how things have moved on, and then we'll move into more of a whiteboarding session to explain some of the pros and cons and things.
Yeah, in general, layer 2 and layer 3 VMotion have many things in common. I mean, in both VMotions, VMotion options, we have VMotion of memory of the state, and we have also VMotion of the disk. And within the state, we can copy the information, which includes BIOS, device information, state, CPU, MAC addresses, and registers, and so on. And So there is no change between layer 2 and layer 3 VMotion. What is the difference is that layer 3 VMotion in a nutshell requires TCP/IP stack or TCP/IP options for VM kernel. VM kernel is a special interface which allows the communication between hosts, I mean servers, and the VMotion. The name host is very frequently, let's say, misinterpreted, which means host means the physical server for sysadmins, whereas for networking guys, usually host is understood as a VM. Here we understand that layer 3 VMotion requires VMK on the host, which is physical server. All right, and what are the requirements comparing to layer 2 VMotion, and what are the principles? So in layer 2 VMotion, hosts or VMK interfaces have to be in the same subnet, whereas layer 3 VMotion, we have an option to route between hosts during the VMotion. So that's the first thing. And another thing in layer 3 VMotion requires to have this special VM kernel interface with the TCP/IP stack option, and this cannot be mixed with other types of VM kernel interfaces. Also, you need to have a reasonable distance between data centers. It is documentation mentions about round trip time at the level of 150 milliseconds. So it allows to do layer 3 VMotion even to the other continent, but of course we have to be careful because of the bandwidth, because of the time, especially when we copy or transfer VMDK, I mean the disk of the virtual machine.
Yeah, I got you. Okay, so before we move on, anything else you want to say in generic terms, or do you just want to work through the diagram and cover it there?
Yeah, just one comment that from the sysadmin perspective, layer 3 VMotion and layer 2 VMotion is actually almost the same operation. It's transparent operation where they move some workloads to the other side, maybe not even geographically different than before, whereas from the networking perspective, it's completely different operation. I mean, we need to provide a proper networking settings, and it imposes a lot of additional work and issues.
Okay, so we'll talk about it when we move into the diagram, but the one thing just to be clear, if we have layer 3 VMotion versus layer 2 VMotion, and we want a stretched subnet in the old world, if we still want a stretched subnet, that doesn't change. So from a networking perspective, we have potentially a layer 3 DCI, but we may still need like a layer 2 overlay in order to stretch the subnet. Nothing really changes from that perspective on the networking side, correct?
Yes, unfortunately, it doesn't change because layer 3 VMotion is doing just VMotion over the routed infrastructure between VM kernel interfaces.
Yeah.
Whereas workloads are attached to the port groups or logical segments. And if we want to keep the communication intact within the specific subnet, layer 2 must be stretched anyway in the way of VLAN stretching between sites, or the overlay networking terminated on the access switches, or overlay networking terminated on the host itself.
Yeah. Cool. I just wanted to call that one out because a lot of network admins will hear, oh, layer 3 VMotion, that means I don't need layer 2 between my data centers anymore. But unfortunately not so. There's still a good chance that you're going to need it in some way, shape or form for different applications.
Yeah, in theory, it is possible to get rid of layer 2 with layer 3 VMotion, but only on condition that every VM or the container is a standalone application without any dependencies within the same subnet.
Yeah. Okay, cool. So I'm just going to quickly explain the diagram, call a few things out of what we've actually got here. Oops. If I can get my pen to play nice. Oh, it's already playing nice. So we basically have a couple of spine leaf topologies, which are the hosting infrastructure within the data center. All this is basically, IP devices which run routing protocols, BGP, etc. And what we're talking about here is we're not really talking about this today, but let's say, for example, we advertise prefixes via BGP, and then we have another mechanism such as, let's just say, Lisp or EVPN or something to advertise host routes. So when the virtual machine moves across here, the host route is injected, and then we have, for example, a /24 plus, the /32 for this server, for example, being advertised out. So that's not all really related to VMware. It's really just to set the scene before I hand it over to yourself.
Yeah, and here, as you can see, we need layer 2 anyway, because if we move one VM workload and the rest of the workloads are in the same data center one still without any change, then we need the communication within the same subnet between the moved the VM and the rest of the workloads. So this layer 3 VMotion doesn't help in that matter anyway. So what additional considerations we need to have in this diagram is that, yeah, we need to consider, first of all, what is the nearest gateway. You mentioned, Malcolm, about host root injection. This allows probably the symmetric traffic. So once we move the VM, this VM can communicate with, let's say, the default gateway, which can be on the nearest either leaf nodes if we have EVPN, or if the EVPN is providing just a layer 2 fabric, then DC core switch. Then our traffic from this VM workload is going outside, and ingress traffic can reach this VM in an optimized way through this host route. If there is no host route, then the traffic can traverse layer 2 DCI link, because it may happen that the data center 1 is the nearest ingress point towards this subnet. Yeah. So this is, yeah? Mm-hmm. So this is north-south traffic in a nutshell. Of course, we don't have, in this topology, we don't have firewalls. If we have firewalls, yeah, we have a cluster of firewalls. So, for example, one firewall is sitting in data center 1. This will be firewall 1, and we will have a firewall 2, which is sitting in data center 2. Then there is a temptation for us that we will use a cluster between those two firewalls. If we have a cluster, then our asymmetric traffic can be appropriately served. But if we have separate clusters of firewalls, the asymmetric traffic will be stopped. of course, there are some trade-offs of having separate clusters of firewalls, because if we have separate clusters of firewalls, we don't have, or we can get rid of fate sharing. But we have fate sharing in this topology anyway, because we're stretching layer 2 between two data centers. Yeah, there are.
I mean, that's like probably a perfect example. Like, not that we're endorsing clustering firewalls between data centers, but I actually got asked by somebody about that the other day. So it does happen, and that's a perfect example that regardless of whether you've got layer 3 VMotion enabled or not, that's another service along with things like SQL databases, etc., that may or may not require layer 2 to continue to be stretched.
Yes, and especially for this common subnet between VM workloads, we still need to provide it, because usually application is built using many workloads and they are communicating to each other within the same subnet group. So this dependency stays as it is, and that's why we need to stretch layer 2 over overlay or using a VLAN.
Yeah.
What is a considerable option eventually is to have a look how this or such a connectivity is provided within a public cloud, for example, in AWS, where separate availability zones do not provide layer 2 stretch subnets. So how do you provide high availability in such scenarios? You just configure separate silos and you load balance the traffic using either global load balancer or DNS or other sort of traffic redirection.
Yeah, and that was actually one of the things that I had listed in the introduction session. So, for example, let's say we had a different data center design where we had global server load balancers and server load balancers. You could potentially escape layer 2 stretching and things like that if you had that type of setup. But most organizations don't have, or small to medium enterprises, which is a majority of what I've worked with in the past, can't afford to put big beefy global server load balancers and things like that in just to they'd rather say, well, how else can we do it? We'll just stretch layer 2, however they do that. So yeah, but that's a good point. So to kind of round off this short take discussion then, Piotr, when you were looking at the stuff and when you were at VMware, did you start seeing more adoption of layer 3 versus layer 2 VMotion?
Definitely not. So layer 3 VMotion is rather uncommon. I mean, okay, it is possible, but and actually it can be done without even awareness of networking department guys or architects, because all the requirements which are met on a short distance by layer 2 VMotion can be met simply by layer 3 VMotion if there is no long distance between data center sites. So the network department can be not even aware of such a VMotion, but generally speaking, everyone is trying to do as simple as possible on their level. So application guys are doing from their perspective as simple architecture as possible. The simplest architecture for them is using just single subnet. Sysadmins are using VMotion because from their perspective this is the simplest thing. They don't need to worry about where the specific workload is located. But all those simplicity creates complexity on the networking level.
Yeah.
So from my perspective, we, as an architects, we need to push back towards sysadmins, towards application guys, developers, to simplify our architecture. But our simplification means that they need to change their mindset or style of configuration or style of developing the application, and that creates a conflict.
Yeah, it can be challenging, but never mind. DevOps will sort all that out, won't it? So we can always hope.
Yeah, that's I think our role right now, to educate other departments. If you, as a networking architect or an engineer, hear, hey, we would like to do VMotion to the other side, you can always say, maybe we can consider a routed topology without VMotion, just replicate storage for such a workload, and have a prepared image for virtual machine to instantiate instantly this workload in the other side during disaster recovery, during a disaster, or during maintenance, or during a specific, migration, let's say. Yeah. I'm not denying that layer 3 or layer 2 VMotion is not useful. It is useful for some migration scenarios, but for the normal stuff like maintenance, like disaster recovery, we have, I think, better approaches right now than just doing live VMotion.
Yeah. All right. Okay, so that's been a great discussion. So thanks again for joining us today, Piotr. I'll just put the background information. If you want to reach out, if you enjoyed this discussion, hopefully you did. If you want to know more or get in contact with us, the details are on the screen, and I'll put all of these in the YouTube video notes. Thanks again for joining, tuning in, and speak to you soon. Cheers.
Thank you. Bye-bye.